Sorry, I didn't realize I was muted. All right, are we recording?
Yeah, we're recording now, so
Awesome. Well, thanks for coming, everyone. There's actually quite a bit to talk about today because we are talking about Spec v3 changes, continuing some of the discussion from last time. But if we're doing things like adding delete vectors and stuff like that, we actually need to rev the Spec version. So I think what we want to understand is how many other changes do we want to target or look for in that Spec v3. So let's start off with highlights, just like normal. So first of all, I want to thank Anton, who is release manager for 1.4. Really great to get 1.4 out. There's a lot of great stuff in there. A ton of bug fixes, and thank you for everyone who contributed to the release. Few things to highlight. I think that number one, the change of defaults is something to definitely note when you upgrade and use this in new environments. So the V2 format and Z standard are now default in our tables. So definitely watch out for that. Z standard seems to be a really good default for data compression. And V2, I think, just allows us to leave some of the old issues from V1 behind, like my early on mistake of not having IDs for partition fields. So really great to have that in have that release out. A few other things to note. There's now a native AzureFileIO. So if you're using Azure, go ahead and check that out. See how that works for you. REST added multi-table commits. So there's now a commit path to do commits across multiple tables at once. I think primarily this is, we don't have multi-table transactions built out in the library, but this is the first step to being able to do that. Right now, you can do like multi-table fast forwards. So if you wanted to do multiple writes and have them all show up at the same time, you can actually use the multi-table commits through REST to do that. Then there are also a number of good changes in Spark to highlight. So first off, remember that we've added 3.5 and removed 3.1. So 3.1 is no longer there. We've added support for a number of new 3.5 features, including adding the advisory partition size, and there's new function push down and other things. And then two more features in Spark more generally, including distributed planning in Spark, as well as the ability to skip a local sort if writes are unordered. Now, basically, that skipping a local sort is going to use the fan-out writer, which was previously not recommended. But now that we're requesting a distribution for the incoming data, we think it's now safe to actually use the fan-out writer. So that is a really nice thing. Skipping that local sort actually avoids spilling to disk and is really nice. So I tested that out, and it worked great. In other Iceberg highlights, moving beyond the 1.4 release, Python moved to the Iceberg Python repo and was removed from main. So if you're looking for Python, definitely go to the Iceberg Python repo. All of the newer pull requests are over there. That project is actually still moving pretty fast. Another thing I wanted to highlight was that we recently added basically a resolver for the write path. So we have objects that keep all of our data in V2 structure in memory, but can actually write to V1. So that's actually a really cool thing. We have support for both V1 and V2 writes now. We're going to, I think, next complete that write path, add support for data files and more commits and things like that. So keep watching there. The 0.6 release in Python should come with basic write support. Also of note is that Flink recently added alter table column, add column, drop column, etc. support. So thanks Yang Zhao Yang Hao, sorry, for getting that in. Really nice to have DDL support and expanding support in Flink. Another one that I know people have been waiting for a while to get is a base Metastore catalog implementation for views. So much like our base Metastore table operations, we now have a base Metastore view operations. And that basically paves the way for view support in Hive and other Metastore-based implementations. The initial support added the features in the in-memory catalog just to get things tested and working. But we expect that the other catalogs will probably follow along. We're working on REST next. At least Edward is, and I think that there are other people contributing support for Hive and Nessie and other catalogs. So really great to see the view support moving along. Lastly, I want to highlight one quick thing on Spark, which is Anton fixed the executor side FileIO cleanup. So now we're correctly closing those FileIO instances on executors. Now, this probably didn't affect most people because you don't have typically long-running Spark jobs, but there was a small resource leak issue that could eventually lead to just having way too many threads in your JVM. So really great to get that small cleanup in. And finally, Rust is moving along, and we added read support for manifest files. So really great to see those things. That's actually fairly far along because you've got to have schemas and readers and some of the expression library. So getting to the point where we're actually reading some of those manifest files is a good point to be at. All right. So that's it for highlights. Unless there's something I missed, feel free to update, paste it into the doc and I'll cover it here. But thank you for everyone who, contributed great features and things in the last couple of weeks. And also really great to see that release out. Next up for discussion, I've reordered these a bit. What I was thinking for today was to sort of come to an agreement or, get a sketch of what we want to do for the Spec v3 changes. A little bit, get ideas from the community so that we can, figure out what we're probably going to target. Of course, this is, subject to like taking all these things to the dev list and adopting v3 formally and stuff like that. But I think this usually gets us on the same page. In the meantime, I wanted to talk about two things that are just smaller issues that I think we can knock out ahead of time. So first of all, I wanted to talk about PR commit methods. So I noticed some merge commits on the other repos, and I was asking Faco like, oh, hey, yeah, how do we set up the squash and merge and things like that we use in the main repo? And there are some options that we can use. And I was wondering, do we want to standardize across repositories to use a squash and merge by default and not use merge commits? Or is this something that, different languages do differently? Just wanted to throw it out there for discussion. Do we have any thoughts on whether you really want merge commits in Rust or, what's going on here?
Yeah, maybe to fill in on Rust, we also have like the linear history enabled. So yeah, merge commits are not allowed there. I think the only discrepancy between the commits between the repositories right now is that Rust also requires to be up to date with the latest main branch. And I think for Rust it makes sense because your CI runs super fast, but maybe that's maybe less nice for Java where the CI takes a bit of time. So I would say like maybe on a project basis we can also make some have some choices there.
Yeah, I'd be reluctant to do that on the Java side because it would require, a rebase after basically every commit, and that's just not real possible on the Java side. We've got people from all sorts of different time zones, and I'm afraid that would be a little overkill, because for the number of bugs it would actually catch, it would actually make merging PRs quite a bit harder, and basically put a time limit on that. So I would probably say no, thank you. I do like the squashing. I think it was the Iceberg Go repository where I saw merge commits. Must have been.
Oh, that's a good one. I haven't checked that one, but yeah, we can also create like a PR there, just standardize it, and see if there's any input there. So
yeah, is anyone from the Go side here to talk about that? Okay, we'll just have to bring it up with the Go community. It sounds like we're mostly standardized on Squash.
Ryan, there's also one other thing that Fako and I noticed as we were looking into the setup for the repos. It looks like ASF Infra has changed what you can configure in the YAML configurations. So I think the original Iceberg repo was set up before they had some of that. And so the actual setup has drifted a little. So we might want to check and make sure that, like, if we want consistency across these, that we actually have the ASF YAML set up consistently across all the projects.
Oh, yeah, yeah.
So I think that, like, ours was set up before they allowed configuring the squash and merge. And so it's just, you didn't even have anything to copy to go set those other ones up.
Yeah.
We can always override this. I think we can talk with the infra. I know for some Apache projects, we'll override the ASF YAML with specific changes. So if it's really required, we can do that.
I think we just need to move over to using ASF YAML to configure these, because we just opened an infra ticket to do it the first time. And so now that infra doesn't require an infra ticket, we should self-host that or self-manage it.
Yep.
Okay, so yeah, let's check that out, and we'll open a PR or two to make sure that we're configuring everything through ASF YAML. Okay.
And I think one more note here would be really nice if people can also clean up when you squash, like clean up the commit message as well, because sometimes maybe that's an accident, but we keep the temporary commit messages, and that basically looks a little bit weird. So usually they have no meaning. It's like fix that for like review comment, whatever.
That's true. I would second that idea that when a committer squashes and commits something, please preserve the commit messages if they're relevant and meaningful. So I know Edward does a good job of adding like text around what he's doing in that commit. But if it's just a whole bunch of one-liners like fix review comments, that stuff, just remove it, because we don't actually need that. So that's a good call out. All right, cool. Next, I wanted to quickly draw attention to the Iceberg docs refactor. So this is something that Brian's been working on. Basically, we've I think it was probably a year ago or so, we moved to an Iceberg docs repository, and then we started using a lot of different branches in that docs repository. But the branches each build the entire website. And so we've got this amalgamation of different sites with different headers, and you have to edit like all the sites in order to make a release, because you've got to add the latest release as the latest to everything. And it's a really big pain for moving. Not only that, having the docs in a separate repository has created a situation where it's hard to maintain. We don't know where like the evergreen content is or what is versioned and things like that. So Brian has a PR up to refactor the docs and move them back into the main Iceberg repo. And this is primarily the iceberg.apache.org site, not the Python docs yet. This is actually a really big improvement in my opinion. But we want to make sure that people are getting more eyes on it, and that we understand how this works. It's very similar. Basically, there's a site folder or a folder of documentation in the main repo, so we're all editing the same thing. There's a script that will deploy docs for a particular version, so you can go check out a tag, run the deploy docs script on that tag, and it will create and stage the compiled documentation into a branch. Then when we do the full docs build, it checks out all those branches to the right places and will create the one big doc site around all of those different versions of docs. So it solves the problem of having multiple different versions of source. We have just one place to edit the main site and all of the front matter and style and themes and things like that. And it solves just a lot of problems and brings the docs back into the main repo to make releases super easy. So please check that out. I think the current plan is to get the PR as it is into the repo so that we can start maintaining docs in this fashion. Then as we update the style of the doc site, because I think it's just standard make docs material right now, we need to find someone to update the style and basically make it look nice like our current doc site. And then from there, we'll go and replace the current ASF docs branch and repoint it back to the main repo. But the first step is getting this big docs PR in and building consensus around what's going on there. So if you have comments, please raise them on the PR. And otherwise, if there's not a lot of chatter, we're probably going to merge that soon and start moving over so that the next release will be using the new doc site. Any comments on docs?
Just quick question for the other languages. Is that a similar model, or are we just focusing on the Java docs, or are we going to eventually pull in because like Python docs have now moved into a separate repo. I assume like Go and Rust will maintain their own localized docs. Is the plan just to say, hey, once those are ready, we'll like do a similar checkout at version for each one of those other repos and like just inline it with the rest of the docs?
Yep. That's exactly the idea. So we'll probably just, everything will be under make docs, and the way that this that it currently works with the different versions of Iceberg docs is it pulls everything into a mono repo. So we'll basically just be extending that out to, like, let's say Python, and Python and the what's it called? And all the, Go and all the other ones are already going to be just version docs. So we're going to pull those in practically the same way. They'll just have their own set of versions, their own set of things that we'll pull in at build time every time we're doing another release. And that's just going to be a one command button click kind of thing. So that way we're not having to have whoever's doing the release think about all those mechanizations. So
yeah, I just wanted to make sure that we were pulling them all together, because we've had some issues with people not knowing about the Python docs because they weren't quite obvious from the main Iceberg site.
Yeah,
so.
The big push here is trying to get all these different documentation with the code. As the code's changing, the docs will ideally be changing with them, maybe in the same PR, but at least at the end of the release. So that's the code will live with each thing, and there shouldn't be multiple repositories that represent the ultimate website / documentation. So that should make it a little more straightforward, hopefully.
Yeah. The other thing here is we're basically going to maintain the docs in main as a nightly branch. So you'll edit the current state of that, and we'll snapshot nightly or wherever we end up placing those for each release. So we'll have basically the most up-to-date docs, as well as the most up-to-date evergreen content that's constantly rolling out. So I think that'll be a really good update as well.
Yeah, and one last little thing. So like in the actual README on the branch that I have out here, it goes, well, here, I actually want to see what the README says. But this has, if you go onto my branch right now, this is all just going to be sitting side by side with the current docs folder. We don't want to remove anything yet in this first PR. And essentially this README will have all of the information you would need to kind of like build this out, understand what we're trying to do here. So I highly recommend, playing with this a little bit to understand how we're pulling all this stuff in and how we use, get work tree and those mechanizations work. And then, once we get to a point where we've all agreed on something, most of this should all be easy to do in just GitHub action. So. But yeah, let me know if y'all have any questions or thoughts on that.
Okay, thank you. So next up, I was hoping to talk about the V3 spec changes. We've been accumulating a number of ideas for a while, including partial updates that we've gone ahead and committed. And there are quite a things to potentially tackle. I was hoping to use this as a way, to get feedback on like what people need and what is important. Now, there are two things that are noticeably missing from my list of Spec V3 changes. And they're things that I think are not going to be there because they're primarily backwards compatible or are breaking changes in and of themselves. So partition stats, we've been discussing partition level stats for quite a while. I think that we have a rough idea of how that would work. And so because that is simply adding to the existing spec in a backward compatible and forward compatible way, there's really nothing that we need to do for partition stats. Now, if we were to decide that partition stats need to be updated on every commit, which I think we've largely gone away from as an idea, then we would need to get something into V3. But I don't think that the larger V3 discussion needs to go down the rabbit hole of partition stats. There are still a lot of unknowns there, and I think we can do both in parallel, unless there's disagreement there or something that is a forward-breaking change that we would need to worry about. Okay, with that,
I also think that I think it fits into the existing realm. I don't think it should be like V3 only feature.
Yeah, cool. I mean, we could definitely do V3, things like I said, if we wanted to require partition stats, then we would need to have that as part of V3. But that I think is like we'll finish out partition stats and then figure out if we want to do anything like that. The main things for the Spec V3 changes are, and again, the context here is, what changes to the spec do we want to bring that actually require breaking changes? So these are things like new types that must be supported in order to support V3. Anything that requires new behavior for data correctness, so like default values support. Any other things that are now valid, even though they were not valid in V2, like type promotion. And then other things that have not been expressed before, like multi-column transforms. Now, multi-column transforms are a debatable part of V3 because the proposal for multi-column transforms actually has a way of expressing multi-column transforms for within the V2. However, this is a forward incompatible change because if you try to actually use a multi-column transform, it's probably going to blow up in the current version. So I consider this something that is most likely something that's V3. And I think if we included it in V3 rather than allowing it in V2, we would just be much, much safer. It might be something where we can, for anyone that needs it in V2, we could have a table level flag, kind of like we did for the snapshot inheritance that we did for V1 that was actually required to be supported in V2. So am I missing anything with this list? I also included 3 more things on the next page, actually, which are location and path requirements. This would be like avoiding double slash and some of the things that we've had issues with in the past, to say like, hey, yes, you can construct anything, but try not to construct locations or paths that are confusing to Hadoop, confusing between object stores and Hadoop. Object stores largely don't edit the paths or normalize the paths. Hadoop does. Owned locations is another structure that is probably backward compatible, but I think that we would want to require for V3. So a list of locations that the table actually owns or has data in. And then the last one is the delete vector proposal, which I think is getting quite a bit of attention, but it's also the largest, I think, departure from what we already do. And so I'm not entirely sure that that would be something that we want to target for V3, although it is definitely possible. So first of all, are there any other forward-breaking changes that people have thought, hey, we're going to need to do that soon, that we want to consider getting into a V3 of the spec?
Hey, Brian, with your location path requirements, I had 2 kind of question comments. One is, does that include location ownership, which has been kind of a big question?
I put that as a separate one. Directly afterwards.
Okay, so then for the path requirements, so the way you stated that sounded like it was more of like strong recommendations as opposed to us saying these are not allowed. Are you actually saying, because like if we're going to put it in the spec, we should probably be explicit about what is allowed and what is not allowed, as opposed to having a recommendation.
And that's exactly why we want to think about this as a potential thing for V3. So there are these situations where, normalization done by Hadoop file systems is altering paths that come in. That has led to some breakages. Now, the question is, if V1 metadata is always allowed, like we always have this backward compatibility requirement. What can we do with location and path requirements? And, is it simply that we want to clean that up as recommendations, or do we actually want to have a, hard requirement in the spec? I think that's still unknown, but if we do want to have a hard requirement in the spec, we need to discuss that and figure it out now.
Yufei?
Yeah, my question is, does location path requirements also include the relative paths related change?
So I did not include relative paths here. That is I think another one that we may or may not want to include. I think I didn't include it because we've had a number of proposals in the past that didn't quite, make it off the ground. If that's something that we want to consider, we can certainly do that as part of V3.
And there may also be options where like a combination of owned locations plus implementation details could kind of address most of the concerns people are having there, where you can build some of that kind of either co-location or closest location kind of logic into a FileIO implementation. And then it's less of a hard requirement for the specification and more of an implementation detail.
Yeah,
think-
I completely agree. Sometimes like so there's another like non-intrusive way or just the implementation details, or for S3 there's access points that could be allowed for DR use case. I think this is mostly for the DR use case. A lot of users really need that. Again, another question, is there anything like we still needed to do for the encryption in terms of the spec change?
Yeah, that was the other one that I didn't think would be part of v3. Encryption is necessarily a breaking change, so it's sort of its own thing. But aligning that with v3 didn't make a lot of sense, because it's essentially like, in my mind, here's my argument. We can go with the encryption spec anytime, right? Because encryption is basically going to provide a way of wrapping metadata. And what we're talking about for v3 is the representation within metadata. Encryption is sort of this thing that wraps around it. So while it is a forward-breaking change, it's really something that can be done in parallel. Does that make sense?
Yep.
I don't know that I explained that all that well, but yeah, I think encryption is definitely something that we want to we want to continue talking about and working on, but I don't consider it part of the v3 table metadata discussion, because it's a separate you know, spec that you'll turn on and sort of wrap v2 or v3 metadata. Okay, so I think we still, in terms of like what we need to do, we should probably figure out the location and path requirements that we want to add. My guess is, because we have to support old paths, we can't really make a requirement that says these paths are valid and these are invalid. We could make a requirement that says in v3 only write paths like this.
Yes.
I think it would still be good to have a strict definition of how locations are constructed and what you should not specifically put in them, like ... or ... / right? Like or ... as a directory or as a path component. I think we can definitely say should not be there, although we can't say it must not be there. And similarly, like empty directory names should not be there, but you might have to actually deal with them being there.
Russell brought this up in the side channel, but if we're talking about putting some of these requirements in, is there anything that we want to include or consider in terms of naming? So like table names, namespaces, any restrictions that we want to put on those? Like we have one like very minor one that was introduced, I think, which is kind of like the namespace separator or something like that. But it's more of an implementation thing than an explicit requirement.
Yeah, so I don't think that we can do that. I mean, so actually it's kind of interesting because I didn't actually review this PR, but it looks like someone added an exception for certain catalogs to be able to pass catalog tests while not supporting / in their namespace, in their names. So there's now a flag to turn off all of the tests for / in table names, which I think we should probably back out, because Iceberg puts no restrictions on those names. So I would be a fan of actually removing those. We worked hard to make sure that you can have slashes in names in like the REST spec, and that's what everything is moving to anyway. So I would be against adding requirements for those names across the board.
Should we add that to the spec though? That like, hey, I mean, just clarify that Iceberg allows all of this.
Yeah, I think that That's a good question. I mean, I thought it was kind of implied that if there are no restrictions on it, it's allowed.
But every catalog has different kind of restrictions and how they convert names. Like glue can't represent a lot of things, and they translate.
Yes, but that's a different problem, because, you know, yes, certain catalogs can't represent certain names. We can't force those catalogs to support more names. What we can do is say these are not passing, you know, full name tests, and so like it is obvious that that's not there. I would say, yeah, we can't force catalogs to support things, and so and I see no reason to say you shouldn't support things like / in a name. So what would we update the spec to say?
I think the question really comes down to, do we want to clarify what Iceberg allows? I mean, right now it's just kind of, it's arbitrary. There's nothing that says what a table name or a table identifier can actually be. But we're not saying that, you know, I guess a catalog's implementation would be to translate it in some way, to provide some sort of conversion. And that's what things are doing right now.
I think it's fine for this to be beyond the spec and implementation specific, because if we say Iceberg supports X, then we're essentially saying that catalogs must handle it. And I don't think this is a problem that needs solving today.
Yeah, if it's confusing, I would err on leaving it out.
Yeah, I agree. Yeah, I think that's probably something to leave out. Okay, so probably recommendations for location and path requirements. I think if anyone wants to work on relative paths, then having a volunteer to shepherd that would be really great. I am a little concerned with the amount of surface area here for V3. New types, default values, type promotion, and multi-column transforms are going to be fairly big projects. I think we're pretty committed to those. Owned locations we've been talking about forever, and I think we need to just take care of that and get it done. So adding more things to that makes me a little nervous. Delete vectors seems to be just happening on its own, and so like let's explore that and see where it goes. Relative paths seems like the other one where, because it's been a couple years, is this something that is important enough to solve in V3, or should we basically punt it? I think it comes down to what are people going to volunteer to push through in a reasonable timeline, because I don't think that we should block to include things like even the new types. Like, I think there are questions on whether we would block a V3 release to include those types.
I think for relative paths, we should probably punt on that, because there's kind of two use cases that people run into: that they're wholesale moving a table, which we can actually provide a Spark action for, to just relocate table Spark action. And then the other one is where they're like, co-locating, or they've got multiple locations and they're doing some sort of like replication case, which is again like the implementation detail of maybe a combination of owned locations and a FileIO implementation that knows how to grab the closest or something like that. So it doesn't feel like something that we actually need to include in the spec in order to solve those use cases. So we probably shouldn't.
That's true. The spec currently puts the spec currently says locations are fully qualified things. But we put 0 restrictions on what that means. So if you wanted to have a relative path as your location, nothing is really stopping you from doing that today.
So I wouldn't say it that way.
Yeah, you're right.
So
parse the paths.
Yeah. I can tell you our problems around this basically come down to, you can't really use relative paths in a table location, because then you're basically dependent on the Hadoop configuration to resolve the authority, which means you can only have a single authority in your entire set of tables being referenced in a single job, which that was like a deal breaker for us. The second issue is we mainly run into this. We basically wrote our own Spark action for moving tables from one place to another and doing incremental copies. And this is running on tons of things because it's our backup method for moving things between regions, moving things between other things. We have folks who've also been trying to do all sorts of stuff with S3 based replication, their automatic replication strategies between regions. And we just have a bunch of use cases, and we seem to just only be doing workarounds to get around it.
I think it does make sense. Ideally, we would be able to copy metadata without rewriting metadata. Like copy all of the files in a table and be able to say, like, hey, if it's at this owned location or whatever, maybe this is just a slight tweak to what we already have. I'd love to see, like, let's move forward with this and see if we can come up with something reasonable and small. Because I think that we don't want to go and say, like, you must relativize paths and, like, a whole bunch of stuff around this. It's also possible to have a multi-homed FileIO implementation. So I'm not convinced that we need to do anything in the spec when you could have, like, your authority be a single authority that gets resolved based on your processing region.
Yeah, so like have the FileIO option, an option for the FileIO that the catalog can say, like, well, this particular will replace the authority every time I see it. Whenever I see the authority, I'm going to use this other one instead.
Yeah, exactly. I mean, that precludes things like, hey, I have a completely different warehouse location in a different bucket, but it does kind of work. Okay. So yeah, let's continue the discussion on relative paths. Then getting into sort of the unknowns here, I want to cover some of the stuff up top. So I think that there's a lot of support for timestamp, with nanosecond and millisecond precision. The nanosecond precision is just a requirement that we're getting from, financial institutions, which makes a ton of sense. Let's just go do it. Milliseconds is one that I wanted to address as a potential. So this actually gets into the type promotion. So we're interested in type promotion because a lot more CDC use cases are using Iceberg. And we need to keep up with everything that can happen in the upstream transactional database. Because if you have a evolution that happens in the upstream that you can't mirror in the downstream, then you have to rebuild the downstream. And that's no good. So we want to open this up and have more casts and type promotions, going from arbitrary type to string and things like that. We've also, for a long time, had people struggle with going from a long that is in milliseconds to a timestamp. And adding timestamp in millis allows us to simply add a cast or a type promotion from a long to timestamp in milliseconds. The bad thing there is if you do have, so the only hole is if you do have a timestamp in millis, we can technically promote to timestamp in micros or timestamp in nanos. But if we are using that as a way to interpret the timestamp millis value in a long, then we would reinterpret those values. So I think we would want to know, do we disallow or discourage type promotion from timestamp millis, knowing that it may be unsafe if you're using that to interpret a long column? Or do we, simply say, we're going to go with the status quo and not introduce timestamp millis to, and basically say, you have to rewrite all those columns if you want them?
Is the question about whether or not we should add millis in addition to nanos, or how to handle type promotion? Or we're asking both.
We're asking sort of both. So I think the argument for adding timestamp millis is the ability to promote along to a timestamp milli, because we know that there's a lot of data out there as a long that people would love to use as a timestamp itself, right? Interpret this as a timestamp. The problem is if we do further type promotion, like if I create a table with a timestamp millis, I should be able to promote to a timestamp nanos and still interpret those old values. The problem is if I've gone from long to millis and then to nanos, I can't actually follow that. There's nothing to say this long was originally a timestamp millis, and so it breaks type promotion if you promote twice. I think that that is probably something that we just call out. We could disallow type promotion from timestamp millis to anything else. We could, well, actually, I mean, if we're going to allow interpreting a long, we could also allow type promotion to timestamp with microseconds, and we would have the same problem. So like there are just some choices that we need to make here on whether or not to allow long to timestamp promotion. And if we don't allow long to timestamp promotion, I think we don't add the timestamp millis type.
Could we specify that we will always promote long to timestamp millis and then do the conversion to any other type? So that at least we're explicit about what the long interpretation is. So you can't use a long to represent micros.
I mean, then we're just, yes, we could. That's another good point. Because it's is that like you wouldn't be able to then promote to, like you wouldn't be able to say, oh, this was in micros to begin with. But yeah, maybe that's okay.
That's okay, because like you shouldn't do that from a long to begin with. Then we're being pretty explicit about a long only represents milliseconds.
I'm good with that. Okay.
For two-string promotion, I worry about one thing there, which is we do have timestamp with time zone now. What does that mean when you can have a timestamp with time zone and you get a string representation of it in an Iceberg table?
Good question. There's also a question of how do we represent floating point values? So yeah, there are some questions around this. Just to finish out the timestamp millis thing for 1 second. If we're always interpreting long as millis, do we actually need a millisecond type? Or is this entirely covered by type promotion?
I feel like
let's say you covered it then with type promotion.
It does feel like it's covered by type promotion.
Okay. I think that it's covered by type promotion as well. So sorry, that was my bad. I think I came back and suggested we add timestamp millis, but the fewer types, the better. So I think we're good there. All right, okay. Jumping back. Sorry, go ahead.
So for the spec PR that I have up right now, I'm going to remove millis. I've added millis. I'm going to remove millis. Now it'll just be nanos. I'm not going to add type promotion because I don't understand that part of it well enough. Unless somebody else wants to layer on that same PR, I'd like to focus what I'm doing, just adding nanos into the spec, then into the code, and then someone else can fast follow me if they'd like to with promotion and other things around that. Is that fine?
I think that is absolutely the best plan. Yeah.
Great. Thanks.
Thank you. Sorry for the swirl here. Okay. So for type promotion, I think that it's possible as long as we have a well-defined output string.
Yeah.
So for integers and longs, it's obvious, right? For time, it's obvious. Although we do need to specify this, because you could have, you know, the ISO value with the T in the middle.
Yeah.
Or do we want a value with a space? You know, do we pad with trailing zeros or not for the different precisions? And finally, how do we represent timestamp, you know, offsets? I think that we would probably, you know, my proposal would be, since we store all values in UTC, we just plus 0, 0, colon, 0, 0 at the end.
I think that's fine. I mean, this is one of those things where people will come back and be like, I have it as timestamp with time zone, but everything I do is in UTC, and then we just have to explain, well, we're really sorry that they defined timestamp with time zone as whatever the client is reading, so sorry. Can't do anything about that.
Yeah. Exactly. And this is, we may not want to allow certain types. So I think, do we want to allow floating point? My answer would be no, because I don't know how to produce a one and only one string from a floating point value.
I would agree with that, but just to play devil's advocate, like, once you're going to string, you're not really treating it as a float anymore. So what does the interpretation, I mean, other than you're right in terms of like, oh, I can't compare these things and equality checks are going to fail, but that's about where you're going to get to, because you don't do, you know, relative comparisons against string representations of floating point values.
I mean, you can, right? Like if I compare in SQL a float column and a string column, it's going to promote the float to a string and run that comparison. I don't know exactly the logic that that everything is going to use, but it seems like something that in Iceberg we typically punt to the engines rather than. And so that's also a good argument for, should we allow the timestamp, right? Should we just say engines are responsible for that type promotion, and therefore you cannot change a timestamp to a string column? I'm okay with that, because I think that in general, you're not going to do that. I think the things that we're going to have to deal with are like int or long to string, because I've gone and changed the format of my, you know, ID. So I went from having an integer identifier column to a string ID column, or maybe, you know, something similar. Date time values, I'm pretty skeptical that you'd ever like promote a date column to a string column.
I think that's a good way to think about it is, what are the use cases that somebody actually need to change the storage format versus what we think of from an engine casting perspective. So integer, long, those are typically things that get screwed up because of like identifiers. You know, the identifier representation changes and now it's actually a string. It was never really intended to be an integer. It was just encoded that way. Whereas a float or a timestamp, typically you're not promoting that to something else so that you can mix in arbitrary strings with a timestamp field.
I was going to say bool as well. I often see like, oh, true and false were okay when we started, but now we actually realize we have like 7 options for that field.
Yeah.
But I agree. Float, timestamp, we end up in like dangerous things. Same for like, you know, UUID under the hood. Why would you ever want to make that a string? It's like a little bit of a dangerous move.
Yeah. So do we want to do we want to be permissive, or do we want to be fairly closed off with this? I think we know bool, int, long to string we should support. Sounds like float, timestamp, date, time, no. Decimal is one where we could do it, but again, why would you?
Yeah. The only reason, Russell, I would argue for UID is because a lot of engines don't support UID as a value. And under the hood, we're translating that to string in like the Spark case. So
yeah, but that's
there. They're like, oh, let's just make it a string going forward.
I think
an
that
engine decision.
That conversion is also straightforward, right? We could go back and forth between those representations, and I would be surprised. Like, I think everyone going from long to string is like, okay, I don't want to have, you know, one-up assignment anymore, and I'm just going to generate UIDs. And so, like, I think you're actually going int long to string in order to accommodate UIDs. Which actually makes me wonder about like that whole use case. Should we have some int or long to UID conversion? In any case, I think cool. Where we're circling around is we need to be fairly strict here, and we're not going to do everything to string. We're going to be very careful, which is how we do everything in Iceberg. Okay.
There's also, just for completeness, the string.format option. Like, if somebody wanted to format their strings in a particular way, then that would solve the timestamp and date problem. But again, if that's not the direction we want to go, then it's good to just close that off completely. I agree.
Well, I think that's an engine option, right? The conversion to something in an engine, we should delegate to engines when that's the appropriate thing to do. I also wanted to cover the possible new types. So we covered timestamp. I think that some sort of semi-structured representation is going to be a good thing. We've had a lot of people asking for semi-structured types, and in particular, like, how do BigQuery and Snowflake represent their variant or semi-structured types? And so I think having some option and specifying this is what you should do is going to be a good thing. If you have opinions here, please speak up. The two unknowns that I would argue for are BLOB, which is basically, let's have a way for people to store large binary objects sort of in a shredded fashion, where we store it as its own file in S3 and store a reference to that file. Now, this gets to relative paths and sort of all those other discussions. I think at first it would be, it basically followed the same rules as everything else. So we're going to store a string that is a UTF-8 fully qualified location, unless we have, you know, some movement on the relative path discussion. But I think that having a blob type is going to be super helpful to actually be able to use Iceberg for unstructured data and essentially keep track of unstructured data along with metadata for those fields. And then finally, Parquet just introduced a float 16 type, which is a half precision float instead of a single or double precision float. I think that there's a good argument for including half precision floats, because there are a lot of cases where a full precision or even a double precision floating point value is just overkill. So if you're, say, normalizing something in a z-score for vectors, like you don't always need the full precision. It is probably an ML thing.
I know they like their node weights to be like very tiny precision floating point things.
Exactly. Yeah. And this is something where we would basically need to determine how we want to store it in the different formats, how we want to represent it, but it is primarily for, yeah, you know, we would almost certainly need a way to upcast it in, say, Spark, or downcast in Spark between float 16 and float 32, which I think is fairly straightforward, but it's a lot.
The other challenge is actually just like the timing on the release of this, because while it was approved for Parquet, it needs to get into a release. It needs to get support, you know, more generally. And then have we looked into Orc and whether they support something similar?
Well, so with Orc and with Avro, we can declare our own logical types fairly easily. So we already do this for like our timestamp types. Now we would want to go back to those upstream communities and say, hey, this is how we're representing float 16. But I'm fairly confident that we could do that pretty easily in those other types. The proposal here for everything is basically treat float 16 like a 2-byte fixed value and store it that way. All right. Sounds like there's general support. I think that one is a maybe, because there's not a whole lot of people coming and saying, hey, we need this. Whereas I've seen a number of use cases for timestamp nanos, semi-structured, and blob. So I think those are probably the types that we'll focus on. All right. The last thing, we're way over time, so thank you for staying, everyone. The last thing I want to mention on the Spec v3 changes is these are great ways to you know, have easy PRs and get them in. So if you want to contribute here, you know, please step up and say, hey, I want to you know, shepherd the, say, float 16 or type promotion stuff. Type promotion itself is definitely a good way to get in. So we'd love more contributors and people reaching out. Awesome. Well, thank you for staying late, everyone.
One more call out, actually, just because it was the last bullet point. I think we got through almost everything. There is a discussion thread about Kafka Connect. And we just want to make sure that if anybody's interested, weigh in on that. We're starting to piece together the PRs to introduce that into the Iceberg library. So there's going to be a whole series of kind of reviews and discussion there. If you're interested in Kafka Connect, definitely jump on those. And I think we have a label for those PRs as well. So you can just look up Kafka Connect for anything related to that.
All right. Thanks, everyone. Have a great couple weeks.
Yeah, cheers.